We now refer to cancer as very much due to related to cancer cells and the microenvironment. And where sugar comes in, along with other micronutrients in the microenvironment that feed both normal and healthy cells, is the fact that glucose is uptaken by every single cell in the body. But because cancer cells are revved up, they are able to actually take that nutrient and actually fuel themselves. So what started as sort of like a well-intentioned interpretation by a non-medical profession has now been really validated, I think, by the cancer research world. Now, because sugar itself sort of quickly goes to stuff you would add to your drinks or your desserts, it all of a sudden becomes kind of a flip topic. But in reality, I think that it's incontrovertible that to cancer researchers that cancer cells avidly use glucose to fuel their own metabolism. So here's where things get more sophisticated. In a typical person, let's say you or I, or someone watching this podcast who doesn't have diabetes, our bodies are able to take any glucose that we introduce by our diet and take it down to a sub-threshold that wouldn't drive that cancer cell any faster than it would a normal cell. So in other words, our endocrine system, our body's own ability to process glucose pretty much takes anything that we introduce in our stomach, and although there might be a quick spike, we'll take it back down within a few minutes. If you've got diabetes, it's a different situation because your hyperglycemic microenvironment that your whole body represents is probably contributing to the growth of that cancer to begin with. And so if you wanted to be safer, if you had cancer, struggling with cancer, and even if your body's ability to process sugar is fine, you might want to kind of stay away from added sugars if you can. But then this is where it gets even trickier. People say, well, then I'm not going to have fruits because fruits are sweet. And fructose is turned into glucose in the body. Again, this is the slippery slope where people who are not biochemists, who are not research scientists, get into that realm where they can talk about the topic and make themselves more confused. I will tell you that although there is natural fruit sugars in a piece of fruit, the reality is when you eat a piece of fruit, an apple, a pear, a peach, something sweet, a grape, you are getting a lot more than the fructose in your body. You're getting fiber, you're getting polyphenols, you're getting all these other micronutrients, many of which can actually fight the cancer itself. And so food as medicine isn't a pill where you got good guys and bad guys and cyanide pills and cure-alls and magic bullets. It's really, food is really a complex mix. And what we're really finding when you look at the evidence, again, evidence being really important, is that by and large, plant-based foods, even ones that have some natural sugars in them, actually help reduce the risk of cancer. The reality is, and I've come to this conclusion after, having been involved with drug development for 20 some years, is that we are not smarter than Mother Nature. Humans just can't outwit the cleverness of Mother Nature. So most of these foods that are we now know are good for us, most of them are plant-based, are enriched with not one, and not 10, but hundreds, if not thousands of different compounds, most of which we haven't discovered yet, that when we actually do study them, they wind up helping our body activate our body's health defense systems so that we can actually better resist disease. What I always tell people is that, why are so many good things in plants? Well, most of the bioactive chemicals, these are the natural chemicals that are good for us, like polyphenols, antioxidants. Look, the plant didn't develop them for that purpose, Plants developed many of these natural chemicals. They evolved them over thousands of years, hundreds of thousands of years, to protect the plant. So most plant bioactives, either help the plant resist insects that are trying to chew them up, so natural insecticides or fungicides to prevent fungus from growing on a plant, or they actually create great, beautiful colors in these plants, which is why it's such an amazing thing to go to a marketplace. You see all the sea of colors that are out there. Those colors attract pollinators, bees, butterflies, moths, wasps, and then help to the reproduction survivability of the plant. And so these natural products, these natural chemicals, are all for the defense of the plant. Now, so what changed is that when humans kind of stopped dragging their knuckles and got up and started to pick off plants, and by the way, non-human primates also eat mostly plants, started to eat these plants, these natural bioactives suddenly took on another job. There was a new job description to plant bioactives, and that's that they started to interact with human cells. And that's where the fun begins, in a way, from a research perspective, because I study food as medicine. I would say I would call my work sort of molecular nutrition. How does the substance in a plant interact with the process in the body? And that when it comes to food and health, it's not just about the food, it's about how our body responds to what we put into it. Put something bad in our body, you're going to mess up those cellular pathways. Put something good in the body. Now the fun part for me is to really try to unravel the mysteries of what it is those healthy bioactive chemicals from the plants and sometimes animal proteins, are actually doing to activate our body's health defenses.
On that topic of health defenses, the area that you're primarily known for is angiogenesis, as you hinted towards earlier. And I think it's still one of those things where people sometimes have an idea, they don't fully have an idea. And you had obviously your groundbreaking TED Talk, which has 5 million views on just TED alone, which I watched when it first came out and I rewatched in preparation of this interview. And you explained in that talk how you got into this world of angiogenesis and anti-angiogenesis and how it's related to many of the chronic diseases that we all know today. So I'd love you to break that down. And since we were talking about cancer earlier, how angiogenesis and anti-angiogenesis links to something like cancer, which we all know of and have probably had a family member who's been impacted by.
Yeah, so angiogenesis is a fancy Greek word that means how blood vessels growing. So angio, blood vessels, genesis, growth of, and it sounds like a complicated word, but 100 years ago, people couldn't pronounce antibiotics and had no idea what that was either. And so it takes time to actually get important concepts into our lexicon. But angiogenesis, how our body grows blood vessels, is a super important process. It's a concept because blood vessels form 60,000 miles of channels, our highways and byways of our circulation that are stuffed inside the typical adult. 60,000 miles. If you were to pull out all the blood vessels in our body and line them up end to end, you'd form a line that would wrap around the earth twice. Enormous a capacity to be able to bring oxygen that we breathe and nutrients that we eat to help feed our cells. So literally, they're the lifelines to our body. Now, our body knows how to grow blood vessels and from the get-go. So most people don't know this, but when your mom and dad met and sperm met egg and started to form a little embryo in the womb, among the first organs to form are blood vessels. Why? Because before you can get any organs to survive, you need blood vessels in place, ready to make sure that those lifelines are actually there. As we are born, we're born with most of our blood vessels already in place, and they stretch as we get bigger and older. So then we wind up actually having, the whole body. There's an exhibit. I don't know if you've ever seen this, called Body World. Yeah. It's kind of like a museum exhibit. It's all about the human body, and what they've got casts there that are amazing, where they've dissolved everything away except for the blood vessels, and you get the entire human figure. It's like the Invisible Man, except they're visible because of blood vessels. That's angiogenesis. That's how those blood vessels got there. Now, here's the thing why angiogenesis is a defense system for health. If you don't have enough blood vessels, your cells, your organs, your tissues are going to die. How do we know this? Well, if you've got a disease like diabetes that hammers on angiogenesis since you can't grow blood vessels very well, you get a wound in your leg, it's not going to heal very well. It's called a diabetic ulcer, leads to amputation. It's really a bad problem. If you're older, if you've got high cholesterol, you've got diabetes, and you have a heart attack, your heart is not going to grow blood vessels to repair itself very easily. And so basically people die because you don't have enough blood vessels to supply tissues that are in jeopardy. Same thing as a stroke. So we know angiogenesis is critical, and our body defends itself by growing just the right amount. What is the right amount? Well, it's not too few and not too much. It's just the right amount. I call it the Goldilocks zone. So remember Goldilocks? The bears are like not too hard, not too soft, just right, not too hot, not too cold, just right. So the body knows how to do this with most of the systems that have been hardwired into us to defend ourselves. And so you get just enough blood vessels, and then there's kind of like a zone where more can grow. Not too many. If you get too many blood vessels, you also get into trouble. Get too many blood vessels growing in your eye, for example. Those blood vessels leak. You get blood coming out. That causes blindness. Diabetic blindness is due to extra blood vessels, excessive pathological angiogenesis growing in the back of the eye. You can go blind. Same thing when older people say, I'm losing my vision. It's usually macular degeneration. That's where blood vessels are growing in the back of the eye and leaking and causing all kinds of problems. So too much angiogenesis is also a problem. So how does the body normally prevent having too much angiogenesis? It's got all these systems to be able to mow the lawn. So think about a landscaper that's trying to create like the perfect lawn in the front yard, right? So basically, if the lawn overgrows, you got to get the landscaper to come in and mow it back down to exactly the right height. That's what the body knows how to do when it comes to our blood supply. Now, cancers are forming all the time. So right here, right now, my body and yours and everybody watching this podcast, we're forming little microscopic cancers in our body right now. Why? Because we got 40 some trillion cells that are dividing, making more cells all the time. You make one or two mistakes in those cells, bingo, you got a tiny little microscopic cancer like a pimple. And like a pimple, it's harmless because it doesn't have a blood supply. So then your immune system wings by, finds it, and cleans it right out. It's like, or your immune system's like a cop on a beat, okay? And it'll take the bad guy right out. However, cancers can become dangerous when they are able to hijack our angiogenesis system. So this is really part of the nefarious, dirty deeds of cancer. They can be harmless and sit in the background in our bodies all the time, anytime. But if they find a way to leak proteins called growth factors that act like fertilizer, and they hijack our lawn, that turf that we're trying to grow, and they grow blood vessels into themselves. And I've done research on this. A tumor that doesn't actually have any blood vessels cannot grow any bigger than the head of a ballpoint pen, the little ballpoint thing. That's it. And it can't get any bigger. It doesn't have enough oxygen, no nutrients. So it's stuck. But the moment blood vessels can touch that little tiny microscopic tumor and start to feed it, a cancer that is the size of the tip of a ballpoint pen will grow 16,000 times in 2 weeks. So this is an explosive trigger when angiogenesis is hijacked and our body isn't able to control it. So that's called tumor angiogenesis. And that's how I got started in this field, because we were at the beginning trying to set out to figure out how do you develop biotech drugs that can starve a cancer by cutting off its blood supply. Well, we've done that. And it's actually one of the mainstays of cancer treatment today. But the more exciting thing, we found that when you use the same testing methods that were used to develop these drugs to test foods, there's more than 100 foods that can actually starve cancers as well. There are many things in foods, these bioactives we talked about, that Mother Nature laced into plants, kind of like Mother Nature's pharmacy with an F, actually can help to mow the lawn and tame those blood vessels, so that if they're growing towards the cancer, you can kind of prune them back, trim them back to normal, and it prevents the cancers from growing new ones, which is really, really important. For cancer prevention, that's just having enough of that milieu to prevent blood vessels from overgrowing can be really important. So what are some of the things? Green tea, which everybody knows has antioxidants, which can actually lower your blood sugars, help to lower your cholesterol, lower your stress levels, your catecholamine, actually is super packed with these catechins, EGCG, the main polyphenol that is anti-angiogenic. So way back when I got in this field, we had a test system where we were testing cancer drugs that could starve a cancer by cutting off its blood supply. And one of the things that I did is I actually dropped some green tea in there, and it was shocking how effective the green tea polyphenols were in stopping those blood vessels that were feeding the cancer. And in fact, if I didn't tell the technician doing the lab work that it was actually a natural compound, and I told them it came from a drug company, they would have been super excited about it and started jumping up and down. And so again, Mother Nature is really, really good. So polyphenols in tea, e.g. CG is one of them. Resveratrol in red wine, also another one that's actually really, really powerful in terms of being anti-angiogenic. Genistein, the phytoestrogen in soy, actually can also cut off the blood supply feeding breast cancer. So it's just the opposite of the urban legend out there that soy is not good for you. I recently saw an article. It was a cover of a magazine that said, soy anti-nutrients or something like that. And my mind was blown that somebody could actually say that, because most of the nutrients, including the proteins, but also the phytoestrogens in soy, again, if you're a scientist, you take a look at this, and the phytoestrogens look nothing like human estrogens. They're not dangerous. They actually block human estrogens, and they actually are also anti-angiogenic, and they cut off the blood supply to breast cancers.